Hello, my name is Faiz and I'll be doing a presentation about the influence of material properties on heatsink. Before we get started, I would like to give a little bit of background about what a heatsink is. Heatsink is a component that disperses heat from another object. It accomplishes this task by increasing the device working surface area and the amount of low temperature fluid that moves across its enlarged surface area. For an example, like a car radiator, they're most commonly used in computers, but also found in cell phones, DVD players, and even refrigerators. Uh, there are a couple of factors that make a heatsink good, which are the geometry of the heatsink, like how is the arrangement, shape, size, or locations of the fins. Other than that, the most important thing in selecting a good heatsink is the material, which is the focus of today's presentation. There are a couple of common materials that manufacturers use to make a heatsink. These are aluminum, copper, stainless steel, and other metal alloys. But the first two is what people generally know and use. These two materials have a different way to process it, as it wasn't straight away ready to make a heatsink. For aluminum, it starts with the mining of bauxites, which is rich in aluminum in the form of aluminum hydroxide. Next, it is crushed and mixed with caustic soda and processed in a grinding mill to produce a slurry. The slurry is heated around half an hour to several hours depending on the conditions until it becomes a sodium aluminate solution. After the impurities have been filtered out, the solution is stirred in precipitates for several days until pure alumina or aluminum oxide settles at the bottom of the precipitation tank. Next, at an aluminum smelter, alumina is poured into a special reduction cells with molten cryolite at 950 degrees Celsius. Then the electric currents are induced in the mixture which breaks the bond between aluminum and oxygen. Finally, liquid aluminum will settle at the bottom of the reduction cell, and then the aluminum is casted into ingots to be used for various purposes, like in this case, the heat sink. For copper, it is a natural material, so copper ore are mined and then grinded into powder. Then the ore is enriched using a process called froth flotation, and any unwanted materials will sink to the bottom. The ore will be heated in air between 500 to 700 degrees Celsius to remove the sulfur and dry the ore, which made it into calcine. Next, the solid calcine is mixed with a flux to make it melt easier and then heated. Uh, some impurities are removed, which form a matte, which is a mixture of liquid copper and iron sulfide. Then air is blown into the mat, forming blister copper, and it is casted into anodes for electrolysis. Finally, the copper is purified to 99.99% by electrolysis. As you can see in the slide here, these are the microstructures of aluminum and copper. Microstructure of a material can strongly influence physical properties such as strength, toughness, ductility, hardness, corrosion resistance, high or low temperature behavior, or wear resistance. Which brings us to our next slide, material properties. Specifically why we have chosen aluminum or copper as the choice of material for a heatsink. At the point which the two objects meet, the faster molecules the faster moving molecules of the warmer object crash into the slower moving molecules of the cooler object. When this happens, the faster moving molecules from the warmer object gives energy to the slower moving molecules, which in turn heats the cooler object. This process is known as thermal conductivity, and aluminum has a relatively high thermal conductivity of 235 watts per Kelvin meter, and copper has a very high thermal conductivity too, of 400, which means the higher the thermal conductivity is, the better the material will direct heat away. Secondly, the material are relatively lightweight too, which is suitable for manufacturing heat sinks that can be big. These metals are both ductile and relatively resistant to corrosion. It can be processed in several ways in molten condition. Its ductility allows aluminum and copper products to be formed close to the end of the product's design. These materials are mainly used for forging parts. According to the requirements for parts, the casting rods needs to have a lower tensile strength and good plasticity to improve forging performance, and eliminate crack defects after the forging process and make the plastic deformation uniform. The material are diffuse annealed after casting. Diffusion annealing is designed to eliminate grain segregation and precipitates in the grain boundaries, and make the structure become uniform in the base and the elements precipitated from solid solution. Ultimately, it can achieve the purpose that eliminating the stress, improving the plasticity, and reducing the deformation resistance. Thank you.